Hey, my name is Jeremy with MedEd Prep, and today we're going to be going over acid-base balance. This is going to be a very simplified version of acid-base balance, and it's not really going to focus on numbers or any other type of tricks, but the big thing is we're going to try to keep it really simple. You're going to watch me build the board out, and hopefully by the end of the video, a few things may be clicking on this that may not have been clicking before. For the human body, the acid-base balance or the pH level is going to be 7.35 to 7.45. And it's going to be a balancing act between your two systems. And it's going to be your metabolic system as well as your respiratory system. Now, pH stands for potential for hydrogen, which is another way of saying a measurement of acidity. So the more hydrogen you have, the more acidic you are. But that's overcomplicating it. All pH is how much acids does your body have. And if it has a lot, it's going to be really low. And that's why in my example, in the way that I draw this out, I put 14 at the top and 0 at the bottom instead of it being flip-flopped or being left to right. This is just the way that made the most sense to me. Because if I add more acids, so here my markers are acids, and if I continue to add them and add more and add more and add more, I'm going to be lower on this scale. And what happens on one side of the scale is going to affect the other. So whenever it is that you're sitting here, you can know that if somebody goes into a metabolic acidosis, they are going to go into a respiratory alkalosis. And that can be a tool to help you out in the future. And that's a tool that I use whenever I go take my exams that I take currently. So to start, we're going to be going over the respiratory side. And again, we're not going to be focusing on any numbers. Your respiratory side is made up of 4 components. So you have your pH, you have your O2, and you have your CO2, and then you have your respirations. Now, your pH that's just going to be up or down. Your O2, how much available oxygen do you have? CO2 is the acid of the respiratory system. So with it being an acid, the more you have, the lower your pH is. And respirations is very different from ventilations, because ventilation is the movement of air in and out. Respiration is the actual gas exchange of CO2 and O2. If you have good gas exchange, it's no big deal. But if you have very poor gas exchange, then it is a big deal. Now, with us focusing on the respiratory side first, we have a few examples that we're going to have. And the big thing is going to be a CNS depressant, a CNS central nervous system depressant, okay? And that's going to be something like opiates, which is a big topic that is used in the respiratory acidosis alkalosis arguments. So, but you're also going to have stuff like benzos. So if you have somebody who overdoses on something like Versed or Valium, they're also going to present with something really similar to the opiates. Now, with that being said, if I have somebody who is overdosed on opiates, what do they present like? Well, they're going to have a decrease in their available respirations, the decrease in their available gas exchange. And with a decrease in that gas exchange, that means that they're going to have a decrease in their oxygen levels. And if they have a decrease in their oxygen levels, that's going to mean that they're going to continue to retain CO2. And as their CO2 goes up, that's going to mean that they are going to have a drop in their pH. Because the more acids we have, the lower we go. Now, another thing to keep in mind is your respiratory side is a very fast system. And with it being a fast system, this can dramatically affect these levels really quickly. If I were to sit here and just hold my breath for as long as I possibly could, my CO2 levels are going to continue to rise and rise. Or if I were to be breathing very fast, my CO2 levels would drop. And that would be something that takes minutes. Okay, whereas your metabolic side, this is a very slow process because it has to deal with your kidneys. Now, with us sticking with the respiratory side, we have covered what it is whenever you have somebody who is they CNS depressants and they breathe very slow, they do not have good gas exchange. Now, if I have somebody who is going to start having a panic attack or just hyperventilating in general, okay? Because you might get asked a question about you're responding to somebody who experienced a traumatic event, they're breathing 34 times a minute, what metabolic or what acid-base derangement would you expect them to be into? And well, it's going to be right here, because their overall gas exchange is going to be elevated, which means that their O2, the availability that they have to bring oxygen into their system is going to be increased. Now, CO2, their body only makes so much CO2 at once. And it's kind of like whenever you have somebody who's working out at the gym and they start breathing fast, they're breathing fast because they're trying to compensate. They're trying to breathe out the acids that their body is making. If you have somebody who is in my situation right now, just sitting right here working on this, I'm not really doing a whole lot. So with that being said, if I start hyperventilating, that's going to lead to a dramatic drop in my CO2 because my oxygen is going up. And I'm removing more CO2 than my body is currently making. And so with my CO2 going down, that's going to mean that my overall pH is going to be going up, and that's going to lead me closer to a respiratory alkalosis. So, respiratory acidosis, not much gas exchange, CO2 goes up. Respiratory alkalosis, a lot of gas exchange, CO2 is going down. Now, for your metabolic side, you're really only going to be worried about your pH, your HCO3, which is also known as bicarbonate. And so bicarb is a base. So if you have more of it, you're going to be more basic. And acids can be any type of acid. And so this can be things that the body produces naturally, like potassium or even ketones. Both of those things are going to be something that we would consider an acid. Or it could be something that you ingest. And that's going to be all on the metabolic side. Now, for this first part, what we're going to be focusing on is we have somebody who has overdosed on aspirin, and so they have acetylsalicylic acid overdose. Well, if they have overdosed on it because they just turned up a bottle of aspirin, what that does is that is going to increase the amount of acids that they have circulating on their metabolic side. And if they increase the amount of acids, the things that are trying to fight those acids have lower availability, and which makes us have a decrease in our pH. Now, if I have somebody who decides that they want to eat a bottle of Tums or a bottle of antacids, okay, so that's going to be an antacid. It doesn't just kill the stomach acid that they might be trying to fight for heartburn. If you have somebody who's constantly intaking too much of an antacid, what that's going to do is that it's going to decrease the available acids that they have circulating in the body, and that means that the body's not going to be in a super great state because it likes to have balance in all things, which makes the amount of bicarbonate that we have go up, and it's going to make our pH go up. So if they have an antacid overdose, they're going to be in a state of metabolic alkalosis. Now, two other things that you're going to see over here on your metabolic side is going to be somebody who is experiencing DKA, and maybe somebody who has missed their dialysis. But we're going to focus in on DKA because remember, what happens on one side is also going to affect the other. So if I have somebody who's in DKA, and we're not going to worry about the other presentations like the polyuria, the polyphagia, and the polyuria. We're going to be focused exclusively on these things. If they are in DKA, their body has an increase of acid or ketones, which is going to be acids because it's diabetic ketoacidosis. So my amount of available acid circulating through the body has increased. And what that has done is that's going to make my body breathe faster to try to get rid of whatever acids it can. And so what that does is that leads to something called Kussmaul respirations. And so what Kussmaul respirations is it's going to be deep and fast. And if you recognize Kussmaul respirations, or you just recognize that somebody could be in a respiratory alkalotic state because they are breathing deep and fast, that's going to tell you a lot of times that they're going to be sick over here and they're going to be in a state of metabolic acidosis, because you're also going to have other things over here like sepsis. Sepsis, DKA, somebody who has overdosed on aspirin, somebody who has missed their dialysis treatments, they're all going to present almost the same, especially with that Kussmaul respirations. So, just to refresh, your metabolic side is a very, very slow system. Your respiratory side is a very, very fast system. We're not doing anything with numbers. We're just doing arrows up and down. If your body has good gas exchange, it's going to have a decrease in CO2, especially if you're breathing fast. If you have an increase in CO2, which is an acid, your body is going to be in a state of respiratory acidosis. So respiratory acidosis, respiratory alkalosis, metabolic alkalosis, metabolic acidosis. What is happening on one side is going to directly affect what's happening on the other. Okay? And that is going to be the key things that you need to know to really succeed in answering most of these questions. Now, it does get deeper. It does get into compensated versus decompensated. It does get into other components, but this is just a simplified version, and you can ask those questions in the comments, or we'll make another video on acid-base or the other parts about acid-base if it's something that you want. So there's going to be a question that's going to pop up right here. It's going to be an example of a question that you may see on one of your exams. And so just go ahead and pause it right here and see if you can complete it. Leave a comment down below. The answer will be in the video description. Again, my name is Jeremy, and if you like this video, please consider liking it, subscribing to the channel, or even leaving a comment down below. You can also always join our Discord community for a more interactive learning experience. Something we are doing is we are giving the first 300 people to sign up on the paid portion of our website 50% off of their first subscription, and you'll be able to see details for that down below. If you are a school or an instructor who's wanting to partner up with MedEdPrep, please don't hesitate to reach out to me at jeremy@mededprep.com, and you will see that link down below as well. I'll see you in the next video.